Welcome to the Passion for Technology podcast. In this episode, we're diving into an article from our latest TQ magazine, exploring the fascinating world of human-machine interfaces. For more details, interesting insights, and valuable infographics, be sure to check out the show notes. Better operation thanks to feedback. The interaction between humans and machines is usually not one-sided, but rather a kind of communication. The operator issues a command and receives feedback on whether the command has been received. For example, with toggle switches, it is the change position, and with push buttons, it is often a certain resistance that must be overcome, sometimes coupled with a control light. Important for operators of many machines is also direct feedback on the force or the angle of rotation triggered by the operating part. For example, an excavator operator can feel the strength of the force with which a shovel penetrates the ground through the resistance of the operating lever of a hydraulic system. The same applies to machine tools. Through mechanical operating parts, force and vibrations are transmitted directly to the hand and body of the operator. With the introduction of electronic controls and operating elements, however, this haptic feedback has been lost. But thanks to microelectronics, the feeling can be replicated in modern human-machine interfaces. In general, sensors detect the force that the human applies to the operating part. If necessary, additional sensors also measure the force or angle at the executing part, that is, the tool, the shovel of an excavator, or the wheel of a car. Microactuators at the operating part can then, for example, cause a noticeable counter movement based on these measured values. The technologies used for this are summarized under the term force feedback. Such systems have been well known in the gaming sector for a long time, for example, with driving simulators. A steering wheel with force feedback technology generates vibrations and simulates gravity. High-end systems dial into the physics and the audio engine of a game to enable an ultra-realistic experience. The player feels in real time the roar of the engine of their virtual race car, the tire traction, the nature of the terrain of the track, and the feedback of the steering wheel. So it feels as if you are sitting behind the wheel of a real car. Force feedback solutions are found not only in virtual vehicles, but increasingly also in real ones, especially in the context of highly automated driving. The classic steering wheel with mechanical steering column is being replaced by mechatronic actuators. This is called steer-by-wire. Thanks to force feedback, however, the mechatronic steering wheel conveys exactly the same feeling as a classic mechanical one. Additional functions can also be realized. For example, a vibration of the steering wheel when the car detects that the driver is getting tired. Accelerator and brake pedals are also equipped with force feedback. Such active accelerator pedals with integrated actuators and freely programmable haptic signals can, for example, help the driver to drive as fuel efficiently as possible. Depending on the selected driving program, a variable pressure point in the pedal travel can be generated, which signals the optimal accelerator pedal position to the driver. Even touchscreens, which are becoming increasingly popular as HMIs, can be equipped with feedback functions. If touchscreens are supplemented by sensors that measure the pressure of the finger on the surface, it is not just touch that can trigger an action, but also the press of a button. The received command can then, for example, be acknowledged by the display with a vibration. This is caused, for example, by electrostatic actuators. This haptic technology is characterized by a stroke of up to 0.8 millimeters, which allows for button-like feedback. Alternatively, piezo actuators are integrated into the display. This technology delivers a stronger and more precise haptic event. In contrast to electrostatic actuators, the deflection with piezo actuators is significantly smaller and is in the range of up to 0.3 millimeters. However, operating elements are increasingly being controlled completely without contact, for example, through glances, hand gestures, or voice control. Until now, users have received control-related feedback in the form of displays or acoustic signals. The Institute of Construction Technology and Technical Design at the University of Stuttgart is currently working on enabling haptic feedback here as well. This involves the use of ultrasound waves. They are projected onto the palm of the hand, for example, as circles, triangles, or moving points, and produce a tingling sensation. Once you have learned the language of these signals, this feeling helps to move the hand in the right direction and at the right speed. Feedback technologies are an important part of human-machine interfaces. They improve the user experience and open up new possibilities for the optimization of safe and efficient workflows. We hope you enjoyed this episode. For more in-depth information on the latest trends and technologies in human-machine interfaces, check the show notes to access the latest TQ magazine, available free of charge.